Right, we've got this inscribed cross, and we're told that the sides of the dotted or the dashed square are parallel to the other square. We're asked for the area of the larger outer square. Okay, let's take a look at this. So the thing that you might look at first is that this and this, it looks to be very similar or the same. And in fact, they are. And let's just prove it because this red length here on the the white triangle is going to be the same as this blue length on the shaded triangle. They both have a right angle. And then, okay, one other argument we can make is that due to the symmetry, like this must be the midpoint of the dashed square, which means that this here must be the same as this because they're all the same. And that's enough to say they're definitely congruent. So what that means is that the area of the dashed square is going to be the same as the area of the whole cross because I can just get rid of that one and put it there, get rid of that one, put it there, get rid of that one, put it there, get rid of that one, put it there. Now I've just got this dashed square on the inside. And the area of the cross is just 5 times 1, so it's 5, which means that this length here is root 5. Okay, we're making headway. Now, similar reasons, this must be the midpoint because this is the same as this must be the midpoint. And therefore, I can work out this length. It's just going to be root 5 over 2. Another way we could have done that would be to say that is 1 and that length is a half, and then we could have done Pythagoras if we wanted to. Right, now let's focus on, I'm going to come over here. Let's focus on this triangle, red triangle there. Now its area, because like I said, this is a half and this is 1. So the area of the red triangle is going to be a half base times height, a half times a half times 1. It's going to be a quarter. But we can calculate the area in a different way. And let me now come down to this triangle. So the triangle here is also a quarter, but now I can use the base and then this length here to equal a quarter. So I know that the base, which is root 5 over 2, and I'm jumping around, it's just to try and make things clearer, but all of these triangles, these little triangles that I have, they've got 1, a half, and then root 5 over 2. So I'm just kind of moving around to different parts just to show different bits rather than doing it all in one place. But let me just backtrack. So I just want to kind of summarize. Right, we've shown that the blue and the red triangles are congruent, so all and around there are all the same. We've shown that that dashed square has the same area as the whole cross, so it was 5, which meant that that green length was root 5. We then divided that by 2 to get root 5 over 2, which was the hypotenuse of each of these triangles. I've added on the lengths in different places, 1.5, and then I've worked out the area of that triangle, which is just a quarter, because I've used the 1 times a half divided by 2. But now I'm using a different way to get the area. It's going to be root 5 over 2 times, let me call it x. And then I need to have it. And that is also going to equal a quarter. The reason I'm doing this is that if I get x, that is also x, I've got the side of the big square. Okay, and then we can work out the area. So I've got a half times root 5 over 2 times x is a quarter. That means that root 5x is going to be 1, x is going to be 1 over root 5. Okay, it's coming together. So now the side length is going to be 1 over root 5 and another 1 over root 5. So 2 over root 5 plus root 5. Let's just write that a little bit better. So we can write 2 over root 5 plus 5 over root 5. It's actually 7 over root 5. And therefore the area is going to be 7 over root 5 squared, because it's a square, the sides are the same. That's going to give us 49 over 5. That is the area of the large outer square. Good question, well done.